Hey guys, today we're going to talk about prime factorization. So first we got to know, what is a factor? A factor is a number that divides evenly into another number. So if I had the number 6, that's divisible by 2 and 3, so 2 and 3 are factors of 6. So are 1 and 6. They are also factors of 6 because 1 times 6 is 6. Okay, let's name some factors of 24. Okay, I always like to write them down in pairs because I don't make mistakes as much that way. So I start with the smallest number. What's the smallest number I know goes into 24? How about 1? 1 and 24. There's a pair. Okay. This is what I'm talking about right here, is a factor pair. It's a pair of numbers that together multiply to be another number. So 1 and 24 is 24. How about 2 and 12? 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. Now, I don't always like to write them that way. It depends on what I'm doing. But generally, if I'm writing out the factors, I like to write them from smallest to largest. So I would write this as 1, 2, 3, 4, 6, 8, 12, and 24. Okay, there's my factors of 24. Okay, so you give me some factors of 18. So just kind of pause the video real quick, write out the factors of 18, and then jump back on and see how you did. See if you got them all. Okay, so factors of 18. How about 1 and 18? How about 2 and 9? 2 times 9 is 18. 3 times 6 is 18. And that's it. That's all the whole numbers. So I would rewrite this, though, as 1, 2, 3, 6, 9, 18. Okay. Now, sometimes when you have something like 25, okay, if I want to write all the factors of 25, 1 and 25, and 5 times 5. Those are the only ones. When I would write these out, I would just write it as 1, 5, and 25. I would not write the 5 twice. Okay? It's already there. You don't need to put it a second time. All right, what's a prime number? A prime number is a number that is only divisible by 1 and itself. It's like 7. The only numbers you can divide 7 by are 1 and 7. The only whole numbers. Okay, 3. 2. Okay, so give some examples of prime numbers. Yeah, we said 2 was a prime number. 2 is, in fact, the only even prime number. Every other even number is divisible by 2, and so it's not prime. 3, 5, 7. Now, not every odd number is prime. Like 9 is not prime because you can divide it by 1 and 9 and by 3 and 3. So you'd skip that one. 11, 13. You'd skip 15 because you could do 1 and 15, and you could do 3 and 5. 17, 19, and so on. Okay, they keep going on forever and ever and ever. So those are prime numbers. Okay, so the brass section of a marching band has 30 members. The band director arranges the brass section in rows. Each row has the same number of members. How many possible arrangements are there? Okay, so you can do this a couple ways. Say, well, I could do 1 row of 30. I could do 2 rows of 15. I could do 3 rows of 10. Can't do 4 rows because I'd have leftovers. I could do 5 rows of 6. Now, you might say, well, you could also do 6 rows of 5. You could do 10 rows of 3. You could do 15 rows of 2, or you could do 30 rows of 1. Now, depending on what you're doing, these are pretty much the same as these right here. If you're looking at factors, you wouldn't want to repeat the factors. But for this, how many possible arrangements are there? Well, if you consider rows and columns are different, then you need to have all of these. Okay, list the factor pairs of the numbers 9 and 35. Okay, so I'm going to let you pause the video here. And I'm going to let you do all the factor pairs of 9 and the factor pairs of 35. Okay, so write those out and then jump back on here. Okay, so I have some factor pairs. I've got 1 and 9, and I've got 3 and 3. And that's it. Now it asks for factor pairs, so I need to write them out like this. If I was just writing out factors, I would just write 1, 3, and 9. Okay? That's not what it asked me to do. Now over here, 35, I can do 1 and 35. I can do 5 and 7, and that's it. So I'm done. Okay, the prime factorization of a composite number. So you got prime numbers are only divisible by 1 in itself. A composite number is divisible by a bunch of numbers. Okay, more than 2, more than itself and 1. So you can write any composite number as a product of prime factors. So like 60 here. 60 has a lot of factors. So here's what we can do: the best way to do it, I think, is to make a factor tree. So you put a little couple branches like this. You go, well, let's see, it's even, so it's divisible by 2. 2 times 30 is 60. Now, this branch here is dead because it's got a prime number on it. So we look at this one. This is still a composite number. That is divisible by 2 and 15. Now, this is a prime number, so this branch is dead, but this one is divisible by 3 and 5. Now, all those are prime numbers, so I'm done. So the prime factorization for this is 2 times 2 times 3 times 5. So this is my answer. Okay, what I want you to do is I want you to write the prime factorization of number 48. So go ahead and pause the video here, do the prime factorization of that, and then jump back on and see if you got it right. Okay, so 48, that's an even number. It's divisible by 2. 2 times 24. 24 is an even number. That's divisible by 2. 2 times 12. 12 is an even number. It's divisible by 2 and 6. 6 is an even number, so it's divisible by 2 and 3. Okay, I've got all prime numbers now. So the prime factorization is 2 times 2 times 2 times 2 times 3. Be real careful when you write these out, because it could be, if you have a lot of 2's, it's easy to leave one off or get an extra one in there. Okay, what's the greatest perfect square that is a factor of 1,575? Okay, so first of all, we need to talk about what's a perfect square. A perfect square is a number that when you multiply it by itself, you get a number that's a perfect square. So for example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on. These numbers right here are perfect squares. Okay, so what we want to do here is we want to do a prime factorization of 1,575. So I do know this, any number that ends in a 0 or a 5 is divisible by 5. So 5 is a prime number. So that will go in there, what, 325 times. Now that also ends in a 5, so it's divisible by 5. That will go in there 65 times. That ends in a 5, so it's divisible by 5. 5 times 13 is 65. So I have my prime factorization. The prime factorization is 5 times 5 times 5 times 13. Now, what you're looking for, though, is the biggest perfect square. Okay? So how do I get a perfect square? Well, let's see. I find a number that when I multiply it by itself, hey, that's going to be a perfect square. It's going to be 25. Okay, so 25, now there's no other, if there was another 5 times 5, there might be a bigger one, but there would be a bigger one, but there isn't, so there we go, 25. Or if there was a 3 times 3 out here as well, then I would take the 3 times 3, make it a 9, and I would multiply that by the 25, and that would be another perfect square that might go in there. Okay, so prime factorizations. So I want you to write the prime factorization for these 3 numbers right here. So pause the video and do that, and then jump back on here and compare your answers. Okay, so 20, I can divide that up into 2 times 10, and then 10 will become 2 times 5. So my prime factorization is 2 times 2 times 5. And I'm done. $88. Let's see. Even number, 2 times 44. 44 is an even number. 2 times 22. 22 is an even number. 2 times 11. No more even numbers, but there's no other number that will divide into 11 besides 11, so this is going to be 2 times 2 times 2 times 11. It's my prime factorization. Okay, 462. This should be interesting. So let's see, 2 will go in there 231 times. Okay, now I'm out of 2's. So am I done? It's 231 prime. Hard to tell. But I do know this. There's some rules about numbers that will tell you when other numbers will divide into them evenly. So check this out. 231. If I take 2 plus 3 plus 1, that equals 6. If I take all the digits and I add them together and that number is divisible by 3, which 6 is divisible by 3, it gives you 2, then that number is divisible by 3. So that means 3 will go into 231. Now I don't know how many times, I got to figure that out. So 3 will go in, it won't go into 2, but it'll go into 23 7 times. 7 times 3 is 21. That leaves 2. Drop my 1 down. Oh, 3 will go into 21 7 times. 7 times 3 is 21. I subtract, I get 0. So this will go in here 77 times. Now this is easy. Prime number that goes into 77, how about 7? And 11. So now I've got all prime numbers, so it's 2 times 3 times 7 times 11. Okay. Find the greatest perfect square that is a factor of 396. Okay, so what we're going to do is start out with 396 and we're going to do a prime factorization on this. So it's even, so 2 will go in there, what, 198 times. Even number, so 2 will go in there. How about 99 times? Did I do that right? let's see, 198 times 2, 16, that's 18, 19, that's 3, yep, okay, there we go. I was right. So that's 2 times 99 is 198. So then 3 will go in there 33 times. 3 will go in there 11 times. So 2 times 2 times 3 times 3 times 11 is the prime factorization. Now, it's asking me for this, though. The greatest perfect square that will go in there. Well, let's see. 2 times 2 makes 4. So 4 is a perfect square that will go in there. But right here, 3 times 3 is 9. 9 will go in there as well. Oh, but then check this out here. This is a tricky one. I got a perfect square times another perfect square. Gives me another perfect square. 4 times 9 is 36. That's a perfect square. That's 6 times 6. So 36 will divide evenly into there. That's my biggest perfect square right there. That's the answer to the question. I don't want to deal with the 11 because the 11 is not a perfect square. It's going to mess everything up. Okay, guys, so here you go. I want you to do this lesson, this page, and this page, numbers 1 through 37, just the odd ones, and I will see you in class.